Thank you, Jim. Can all hear me? Yes. At the back as well? Yeah, good. Right, so before I go into the material, just want to mention that I'm working for the Science Center for Embedded Software and FPGA, called Lucas, as Jim mentioned. And we'll have a major focus on efficiency and quality improvement, which is part of the reason why I'm here today. If you want more information, you can just have a look at the website. So, before we dive into the FPGA stuff, let's have a look at the broader picture. Let's have a look at the Norwegian electronics industry. Because it's a really strange thing when I talk to people from outside Scandinavia, they have never heard of any electronic industry in Norway at all. What they have heard of, however, are things like this, the midnight sun. Or perhaps this. Now, I've heard some rumors that the person to the right here is actually searching very, very hard for the Norwegian electronics industry. So that must be a very frustrating experience. So, is there actually any such industry to find in Norway? Apparently not. Well, or at least we may conclude that the electronics industry is not the best profiled industry in Norway. So let's go beyond that and let's have a deeper look. And I think it makes sense to actually start by looking at the Norwegian ASIC and IC industry because it's so closely related to the FPGA industry. These companies all have products that are sold worldwide. As you can see from the slide here, some of them have been acquired by large international companies. But they are still fully operational in Norway, making advanced products and succeeding globally. So at least this means that we do have at least an ASIC IC industry in Norway that is doing well. So now let's go into the FPGA industry. In Norway we have a major diversity in FPGA projects in the use of technology, performance, applications, anything from seismic to ultrasound, imaging, satellite communication, you name it. And the strange thing really is that these companies are succeeding despite the high level of cost in Norway. I'm not going to go into all these companies. I just want to mention or list some of the companies that are doing quite well, making good products and actually succeeding despite this high level of cost in Norway. And now I want to go into just talk about a couple of these companies in slightly more detail. One of the companies, this company called Cisco, you've probably heard of it, was originally Tandberg until it was acquired by Cisco 2 years ago for the net sum of $3.3 billion. It's quite a lot. Cisco is making video conference systems, and they have a major development group here in Oslo. They use FPGAs extensively, as you can see from this plot here. They actually have six FPGAs in this codec, and they're all actually very advanced. It's another company called Orotech Ultrasound, making sort of general purpose ultrasound systems. They're based in Trondheim, which is about 500 kilometers north of Oslo. Quite a small company, but doing quite well. And I was told earlier today that they have a data processing chain, which is actually more than 1,000 stages deep. That's quite impressive. If you look at the specification here, you can see that it has a huge computing power, an amazing computing power, and also amazing input data bandwidth. Kongsberg Defence and Aerospace is a large company in Norway. The department here is located at Kongsberg, which is about 100 kilometers west of Oslo. And in this product, they're making an FPGA to control the solar array for a satellite. And this satellite is not moving away from the sun like most satellites are doing. It's actually moving towards Mercury, towards the sun, into a very, very hostile environment. So it has to be a very, very fault-tolerant system. And FPGA is part of that. And the use of FPGA in these kind of applications is actually quite new. I was told last week by one of the major technology vendors that the Norwegian distribution market is actually about the same size as the Swedish distribution market. And that is quite remarkable because the Swedish electronics industry is about, or more than 10 times the size of the Norwegian electronics industry. And that means that we are utilizing FPGAs a lot in Norwegian products. Basically, we use FPGAs for everything. I make lots of really complex FPGAs. We're pushing the limits on technology, pushing the limits on performance, and pushing the limit on resource usage. I think I should also mention that there are lots of medium complexity designs being made in Norway. And the reason I mention that because these medium complexity FPGAs are actually quite complex today as well. So that means when you look at the fact that was mentioned earlier today that FPGA development tend to be sort of more time-consuming, more error-prone than, for instance, software design. That means we must assure the right quality, and we must also make sure that we're getting more and more efficient. And this is sort of the core of my work when I look at or work with the improvement in quality and efficiency. And what I have seen through at least 15 years of consultancy is that most self-inflicted quality and efficiency problems have the same few root causes. And by self-inflicted, I exclude things like the quality of IP and quality of tools and so on. The first of these problems is actually the lack of structure in design. And it seems that hardware designers, FPGA designers, are less structured than software designers when it comes to designing. When it comes to verification, they are even more unstructured. And some people have said that it's really difficult to understand another person's design, but understanding another person's test bench is normally quite hopeless. There's also a problem with lack of simulation. The third area we see as a major social problem is timing and clocking. Of course, we have the normal problem with timing closure, where you try to reach a certain frequency. But it's actually more of a problem with the internal clock domain crossing, causing a lot of problems, errors, and delays in the projects. And the same goes, of course, for external I/O timing and clock domain crossing. These problems are not particularly Norwegian problems. These apply worldwide, of course. So what is the FPGA world doing about this? Well, in my opinion, there's an imbalanced focus on improvement activities. So if you look at the graph here, that represent the quality of work done in an organization with respect to design, verification, clock domain crossing, timing, and so on. Then what I have seen is that there are very few advanced companies and lots of companies that are not advanced at all, not mature at all when it comes to methodology, structuring, and so on. And tool vendors and academia tend to focus on the most advanced needs of the FPGA community. Tool vendors, of course, because that's where the money is. And I think academia because the challenges are probably, there are more challenges there, and it's probably more fun to work with the most advanced needs. And of course, we have to have a focus on these advanced needs to actually make the industry go forward. But there's also an insufficient focus on the needs of the majority of the industry. Because these companies, they need help at their level. They don't need the same kind of support, the same kind of tools, the same kind of methodology as the really advanced companies. They need help at their level. I'll use verification in a minute to exemplify. So if we look at the state of the FPGA community, then these are my experiences anyway. And that is, most companies, they do not simulate sufficiently at all. They have terrible test bench structures, as I just mentioned. It's impossible to understand most of these test benches for another person. And most designers have insufficient knowledge about verification, test bench, verification plans, and everything that has to do with verification. And maybe even worse, most companies have insufficient awareness of the importance of verification. And that's really bad, because that means they're not focusing on improving either. So what do we need? If we again look at this distribution function, if you call it that, of how advanced companies are with respect, for instance, to verification. Yes, of course, it is important to focus on the most advanced needs in a business. We have to do that, because some companies really need it, and of course it's also driving the complete FPGA community for the future. And it does give a major improvement potential, and it might actually be a showstopper if we don't have those tools for these really advanced companies. But, and there's a major, big, fat, red but, the large majority, they have totally different needs. They need more awareness. They need actually to know why they have to do this proper simulation, why they have to make good structured test benches. They lack the knowledge, they don't have experience, and they need structure, as I said. Structure the design flow, structure the documentation, their architecture, their coding, and structure everything, and they are unstructured. They have to be aware that they have to make self-checking test benches, they have to have a certain coverage, they even have to be aware that they need to make test benches, test cases that actually generate reports that you can understand and use for debugging. And they have to do this step by step. You can't tell these people to use System-Verilog and VMM. It's far beyond their level for most companies. There's a huge potential for improvement. And I would say if you look at the number of man-hours in an FPGA project of, say, 3,000 to 7,000 hours, I think the potential for savings is about 20 to 50% for most of those companies. So that means a huge saving is possible. How do you improve verification for this large majority? I think academia can do a lot more in the education. Much more on practical approach, on structure, and more on the quality in the development flow. Focus more on verification, focus more on structure. And maybe all the boring issues like documentation, like clock domain crossing analysis and everything. When it comes to research for the future, of course, academia must do that, and they have to focus on advanced needs. But maybe they could also focus slightly more on industry-friendly approaches, because not everything that comes out of the new tools are easily used by the industry. Tool vendors, I think they need to address every single company at their level. So that means when they address a company with insufficient verification, they cannot sell them the expensive, the advanced tools. They have to actually approach them at their level. When they do that, you can actually bring them up, and then maybe later they could be customers of their really advanced tools. So basically what I'm talking about is best practices. And there could be many best practices, but at least some kind of best practices. But this doesn't seem to have very much attention. If you look at all the courses that are available, there are technology, languages, frameworks, etc. But there's apparently nothing on FPGA development in general. Maybe they think that this is something people know about, or should know about, but they don't. Maybe this could be a responsibility of the university, I don't know. In Norway, we saw this problem, and we actually made a dedicated 2-day course on best practices, just to handle these issues, to make sure that you improve the awareness and actually tell people how they can actually improve their structure on the design side, on the verification side, and how to handle the various difficult issues when developing an FPGA. As you understand, I'm very much a fan of sharing knowledge and experience. And back in 2004, there was a Norwegian intercompany corporation called Emblem. And the intention of this organization was actually to focus on high-level system development for ASIC and software. Mainly UML for system on chip and system C actually. But there was a byproduct in this small organization called platform-based development. And that group had a totally different approach. It was a much more practical, pragmatic approach where the different companies should learn from each other. So many of the major companies in Norway came together. They presented their development tools, flows, and experience, and we all learned from each other, and that was really useful. Another thing that existed at that time was something called FPL2012. At that time it had been running for 20 years. It was mainly meant for ASIC and embedded system design, but also for RF, analog, the circuit board, and also some FPGA. The problem was that the number of participants was steadily declining. And the reason for that, we found out, was that it was too academic for the industry. It was too broad for each individual. That is, to actually find something that was of interest to you. And it had insufficient support from the industry. Maybe because of the 2 previous bullets. But it had a very good concept. And especially for networking. I'll come back to that. And the FPL2012 coordinator, Leif Ross, was very open to new ideas. That was really great, because then we could take the experience we had in the MLAB, the platform-based development group, and try to merge that with the very good concept of FPL2012. And in 2005, we had a joint seminar for FPL2012 and FPGA-forum in Norway. Now, the focus of FPGA-forum was really clear. What did we have to do? We had to make it less academic and less focus on potential future tools, languages, and so on. And be more so pragmatic and practical. And narrow focus, one single subject, FPGA only. Something of interest throughout the seminar for everyone. And also focus on the daily work of the designers. And another thing, minimize direct marketing from the vendors. All the vendors are asked every single year to minimize direct marketing and rather have indirect marketing through good technical presentations. Most of them listen to that, not everybody, but it helps. Another thing which is really important is that 50% of the presentations are from the Norwegian industry itself, on project tools, methodology, and so on. And I think that's one of the major reasons why this is successful. But it's also a very tough job to get all those companies to present their work. Networking is an important part of FPGA-forum. The dinner party on day one, that gathers 95% or more of the participants. So it's an excellent place to meet people and talk. And also mention here that experience showed that it was important to have this event outside Oslo, because when it was here some years ago, people tended to sort of just drop by and go home in the evening, so there was no social event in the evening. Now the event is in Trondheim, 500 kilometers north of Oslo, and as I said, 95% of the participants stay for that dinner. And lots of senior developers and decision makers coming to this seminar. So today, this is a two full day seminar. Two separate tracks, everything on FPGA. We have international keynotes, and the keynotes for 2013 will be Dennis Segers from Tableau. And we also had some excellent speakers in previous seminars. We have 120, 130 participants. It's a paid event, and maybe that's also a clue, because I think a paid event means that more of the senior personnel are coming to this event. Also, the dinner is included. It's no option not to pay for the dinner. All the major vendors are present, and a really great input for us in the organizing committee is that they have actually said that they are very pleased with the quality of the participants, as I said, because there are senior designers and decision makers. High quality presentations with very good feedback from the participants. And I think this helps the Norwegian FPGA community improving. So I think this is actually a very good concept. Yeah, I think we forgot the date on the leaflets, so... So to summarize, there is an electronics industry in Norway. Part of it is actually really advanced. And I think we need to have more focus on the needs of the majority of the industry. And with more focus on that, we can actually reduce the workload a lot. As I said, also the FPGA-forum contributes to a better FPGA community in Norway. And I think the most important here is that you need to focus on the needs of the industry to be successful with that kind of seminar. Okay, thank you.
Thank you so much, Espen. You have been really good at keep it with your time here. So that will leave a minute or two for questions. So please, any questions to Espen?